Good morning, everyone. Welcome to another episode of Xah Talk Show. Video check, audio check. I'm good to go. Today is 2021, July 21st. Today we are going to do emacs lisp coding for the first 20 minutes or so, then probably Wolfram Language coding, just like yesterday. So, so if you have comments, questions, post it, okay? So let's start coding emacs lisp, okay? So let's see what are the things I want to do. So here is write a command to combine HTML skip tag backward and HTML skip tag forward, okay? So, hey Emily, good evening. So emacs lisp coding, so we are going to code HTML. So here is what we need to do today. Show in browser. So yeah, that's the one. So let me explain what is it that we going to do. So okay, so tag forward. Okay, so you see, let's magnify this. So you see there is a end tag. Now I want to jump to the beginning tag. I want to move cursor to the beginning tag. So what I do there is a command. Now if you look at the pink window, you will see. So I call this command. I press two keys. You see my cursor is here. So that command is called skip tag backward. Now if I'm on this tag, my cursor is here. I want to jump to the ending tag. I press a key. Then I'm at the end. Now, however, the problem is that, you see, you have two commands. Now, when you jump to the beginning tag or the end tag, basically you don't need two commands. You just need one command. The command can figure out whether the current tag is the beginning tag. If so, it'll jump to the end tag. If it's the end tag, it'll jump to the beginning tag, you see. So that is so you don't need two commands, because when you have two commands, you have to think, oh, I'm at beginning tag, I need to call, go to the end tag, then you do it. So one command, you just go back and forth, which is similar in emacs lisp, Xah emacs lisp mod. For example, let me show you. Okay, Xah emacs lisp mod, define. Okay, so if I'm cursor is here, I can press one single key. Look at the pink window. Okay, one single key to go back and forth of any parentheses. You see, you don't need to think about whether you are on a beginning tag or end tag. So let's code that. This should be pretty easy. Okay, so emacs lisp start a empty bracket. The empty buffer. Then define. Okay. Then xah-html jump to what's the name? Begin end tag. Okay. So the naming is unsure because this is too long. xah-html jump to begin or end tag. This is, the proper name would be that, but it's kind of too long. So what is a better name? Hello, not Jake. I'm not sure what is the better name. So jump to begin or end tag. Let's go with that. Okay. If you have suggestions, post it. Okay. Version. Can you use that to select everything between the two tags when you also hold shift? Yes, you can write a command to do that, but however, I do not recommend any command with I do not recommend the key, code key. Typically in programming languages, you have shift select. That is, you hold the shift key, then you can press arrow down and you're selected. I turn it off in Emacs. So let's save it. Okay, let's save this and the VS Code. Let's open in VS Code. Let's show that in VS Code. So you see, can we magnify the cursor? Yes, we can magnify the window. So I hold down the shift key, then I can press the arrow key. That's no good. Okay, this is a this is a inefficient way to select text. So close the Visual Studio VS Code. Do you want to save changes? Don't save, okay? Close the Visual Studio. So yeah, so I recommend do not use Shift Select and for any command. So rather, the more efficient way is actually to have a keystroke to begin. Actually, the most efficient way is you just have a single key for a command to select what you want. For example, I can select the current word, or I can select the current line, or I can select the current paragraph, the text block. Let me show you the pink window so you can see, okay? Select current line, or select the current block, or I can keep pressing the key or keep selecting the block. Or if I'm selecting a line, select the line. I want to select the next line too, I can keep pressing the key. Or if you want generic selection, for example, from this to here, then the efficient way is to have a command that start the beginning of selection. Then you move your cursor to wherever you want, okay? So don't use Shift Select, that's an inefficient way. Okay, so let's go back to the code, okay? So let's begin to jump to, we want to write the tag, okay? So the name is descriptive enough. Now let me find out what's the command I need to call, okay? We are starting to write this. Actually, the command call is here already. So let's put them here, okay? So here we have, basically, we are going to, first of all, determine whether the cursor is on a beginning tag or end tag. Then call one of these commands, okay? So that is easy because I already have a code to do it. So let's open a new window. Let's look at xah-html mod. Okay, so this is. So go to space H. That is a keystroke to turn on xah-html mod. Then you go to the source code. Then you list matching lines, all lines about define. There is a command that tells you whether you are on an opening tag or end tag. So there it is. xah-html is opening tag P. Now P stands for predicate. In Emacs, in Lisp in general, there is a naming convention. When a function ends in P, that means that function is a predicate, which means basically that function returns true or false. Now this is so in Common Lisp, in Emacs Lisp, but in Scheme Lisp, they use a question mark at the end instead, which is a better convention. Because, predicate is from logic predicate, but the programming language predicate, the meaning of predicate is actually different from the logic's predicate. Kind of similar, but actually very different. Because in logic, a predicate is actually a statement that says it's true or when you have a predicate, it make a statement. In a programming language, when you have a predicate, it just returns either true or false, okay? So in logic, you see, this is a pen, that's a predicate. It's not a question. In programming languages, is this a pen? -p in Lisp. That's a question. It returns either true or false. So that's a major difference. But anyway, that's a convention, predicate, okay? And by the way, in Mathematica, in Wolfram language, the convention is using Q. Okay, I'm starting to digress, but but why not? I have an article on that. So you go to XAH homepage, then you go to this is interesting, because I've been doing Lisp coding live for so many videos. Let's digress a little bit. So you go to syntax loop, semantic noodle. Let's try semantic noodle and search for predicate. Okay, it's not here. Then you go to comp land perving. All these videos are great. You should go watch it. Okay, comp lamb perving. Then search for predicate. Where is it? Syntax soup. Let's go to syntax soup. Search for predicate. There it is. Computer language. Predicate function, terminology, and naming convention. Let's open that. Magnify. So here in this article, I explore the meaning of first of all, I explain the meaning of predicate in logic and in programming language. Okay, meaning of predicate in logic and computer science. Then actually it should be computer programming languages. Okay, then I explain the various conventions in programming languages on how they name their functions, predicates. So in emacs Lisp, you have all these examples of predicates: integer p, function p, file readable p, file exist p, string p, symbol p. But actually, it's not very consistent in Lisp because you see. So ideally, any function, if it ends in a -p, then that returns true or false. But that's not the case in emacs Lisp, at least. And I don't think that's the case in Common Lisp neither. Because, first of all, you have inconsistency of the syntax of the naming. Okay, so some ends in -p, some does not end in -p. Okay, that's first problem. It's a problem. Okay, language design problem of the Lisp. of the Lisp faction. Now there's also besides that, also it's not true that any function name ends in p means it's a predicate. So do we have an example? Did I show an example here? Yeah. For example, here you see pop define group make sparse key map forward sexp. Those functions ends in p. But that's not those are not predicate. They don't return true or false. So Lisp, this is a flaw in Lisp programming language design. Okay. Now we look at scheme Lisp and closure Lisp. They did better. They did excellent. Any predicate, if a function ends, their name ends in a question mark, that means it returns true or false. That's it. Period. Simple, logical, and systematic, consistent, no exceptions. Okay, great language design of the syntactic. This is, naming of things actually belongs to the syntactic issue of the language. Okay, so scheme and closure Lisp, great design. Now Wolfram language. Wolfram language went one step further, okay? That's why I love Wolfram language, the design of Wolfram language. In Wolfram language, a predicate always ends in a Q, capital Q, for question, okay? Why? Because, when you design a language, you actually think about things, So why do they Lisp, for example, Lisp or scheme Lisp, closure Lisp, they end in P? Well, that's a tradition. That's a computer science tradition. P is predicate, okay, predicate. But who understand what the fuck is a predicate, So in Wolfram language, Stefan Wolfram, he has his way of thinking, which oftentimes I agree with. So he just named it Q. Q stands for question, okay? If a function ends in Q, capital Q, it returns either true or false. But why not question mark? Well, question mark is actually a better system. Well, Wolfram language cannot use question mark because question mark is used. It's used on. Why can they not? What did I explain? Well, basically, they have a convention, okay? In Wolfram language, there's a naming convention. Every built-in function is a camel case starting with a capital letter and no punctuation symbols whatsoever. So every function is just a alphanumeric sequence of camel case, no punctuations. That's why they cannot use question mark. So you can see there are several design issues and constraints. Once they decided this is the naming convention for all functions, then, of course, then you have the disadvantage where you cannot have a question mark in your language. But however, you see, there's also a flaw with question mark. You see, yeah, it's great if you have a system where any function ends in question mark, means it's a predicate, return true or false. But however, you got a problem now. Now, if you allow question mark in function names, then there's no prevention of any people naming something question mark that, okay? So people can use that as a function name. So what does that mean? So you got other disadvantages, okay? But anyway, Wolfram Language, they choose the convention of ending in Q as a predicate, okay? And here are all basic, I think that's not, these are not all of them, there are more. And Ruby, okay, Ruby is also a great design. They follow the scheme Lisp tradition ending in Q, so that's great. So, okay, that's a digression about the naming a predicate in programming languages and what does it mean in logic, okay? So let's go back to talk show and common, okay? Back to talk show and let's post this we talked about, okay? Now let's go back to code emacs Lisp. Where is it? So Wolfram Language, okay, so close that. Where is our Lisp code? Here, okay. So yeah, we're gonna call this function. Good morning, Pablo. So actually writing this function should be easy, okay? Open is open tag, okay? Let's create a variable, set that variable, and that is our variable. So then if, actually we don't even need a variable, so let's keep going. Let's not fuss about the formatting or style of coding stuff. So if it's an open tag, then skip tag forward, okay? Then otherwise skip tag backward, okay? Prettify the code, that's it. Evaluate the code, then copy that. Let's go to a HTML. So what is this page? Programming blog, okay? Close. Go to talk show. Let's test it, okay? So let's put the cursor here, okay? Then call meta-x xah-html jump to begin or end tag. Do it, fantastic. Now move the cursor here, call it, fantastic. Now what if the cursor is here? Will it consider this or will it consider that? So I don't know, let's try it. Okay, it actually consider this tag when your cursor is here. Anyway, those are edge cases you have to. So basically we are done with this function, but however we need to refine it. We have to consider about edge cases. For example, if my cursor is here, between this end tag and between that open tag, where does it jump to? Does it jump to here or does it jump to there? So I don't know. Let's try it. Okay, it jumps to the top in this case. What if my cursor is here? Let's try it. Okay, it still jumped to the top, but if the cursor is here, it jumps to there. If the cursor is here, okay, I'm not sure exactly what is the behavior. So anyway, we have to refine that. And in order to do that, we have to find out what this function do exactly when it is between open and close tags. But first of all, we can. Okay, I think I should move on to Wolfram Language, shall we? So we talked about 30 minutes. Great. Yeah. So delete that, paste it here, prettify, show in browser. Fantastic. That's our code. Let's move on to Wolfram Language, shall we? Yeah, because I've been doing so much Emacs Lisp in the past few months, I want to do some. Okay. We don't need that in a window anymore. Unless you guys have some questions you want to bug me. Then we're gonna, otherwise I'm going to go into Wolfram language coding, Borg cube. Borg cube is fantastic. Oh, it's actually, this is not Borg cube. This is just me testing something. What is this? This is not Borg cube. This is testing internet. Okay, this one I believe it's testing. It's plotting internet speed growth over the decades. You know, basically you want to know how fast does internet speed grow. You know, we know that the CPU speed grows about 1.5 times a year, something like that. You know, they say double every 1.5 years or something, or 2 years. The hard disk also grows similarly. So, but how about the internet speed? Okay, so that's what this is about. I have an article on that. Let's go show it. Okay, so go to XAH web page, go to there, and go to technology, past and the future. Then you go to, do we have a chart here? Internet speed. Basically, it grows also similar to 1.5 times a year. Yeah, here. So internet speed growth rate. So yeah, so this is a plot from that notebook, and I need to do this in JavaScript. Yeah, so basically it grows 1.5 times the factor of 1.5 a year. And right now I have 160. Let's see how much is my speed. Can we? My internet speed, Google does it. Let's run it. Sucks. It sucks. It should be like 100 a night, I think. USA internet speed is pretty low in comparison to many other countries. 70 megabits per second upload. So that's slower also because right now I'm doing live stream. Okay, so that's that. So this is Wolfram language. I want to tell you, okay, anyway, this is not too interesting. Okay, this is just a bar chart. I want to do, actually, I don't know what I want to do. Okay, this is a notebook I did like 23 years ago. And today there is a lot, today there is a built-in graphics primitive for drawing tubes. You see, what I want to draw here is 3 tubes, helical tubes. This is done in, do I have a year? 1997 or something like 1997. Okay, and but today, so the way I did it is that you build each and every of these. Can we still evaluate it? Let's try. Okay, continue with updated styling. Okay, do it. Okay, clear, do I need, oh yeah, need geometry rotations, that's obsolete. So I cannot, if I run a code, it will not work because this package is obsolete about 2006, I think. Because in 2006 Mathematica version 6, they have all these functions built in. So instead of using the function in a package, all those functions are built in. So anyway, so the way I did it, you start with 3 circles, then you extrude. Extrude is a operation in 3D geometry. You basically like you grow buildings, okay? But every time you grow it, you move it a little bit. So that's how I build these graphics. Then you build the polygons, the triangles between the 2 circles. So it's quite tedious. But today you can draw these. Since 2006 or something, it's been 20 something years. There's a built-in primitive. Let's try to do it, shall we? If I do this, it's not going to be useful to myself because actually I wanted to do something more relevant. Aloha Braveheart. Are you in Hawaii? So let's get in touch with you guys. What are you guys doing? So should I try to generate this using Wolfram Language, or should I do something else? Because I was thinking of working on my my tilings package, which we talked about yesterday, plain tilings, okay? All these packages I need to work on. Any comments? Transform 2D plot, okay. Which we talked about. Dubai. Oh, in Dubai, amazing. Wow. So do you speak Arabic? You were born in Mid East Arabian. Are you like, how do you describe the race of people there? So let's try the tube, okay, since we've been talking about that. So actually, oh, so you do, so you are, so amazing. Okay, so what I want to do, so I want to helix cubes untitled, it's graphics 3D, okay? Let's turn on help. Magnify. Graphics 3D, so I want to find the tube primitive, okay? So the structure of graphics, interactive graphics, polygons, polyhedra. The structure of graphics, okay. Yeah, that's too that's kind of too much. I need to find the primitives, built-in symbols. Let's go to solid geometry. Actually, we can just search for so there is the built-in primitive tube, okay. Okay, that's getting complex. Graphics 3D cube. So tube takes two arguments. The first argument is the beginning and end position, a coordinate, two coordinates. The second argument is thickness, okay. But I want it to be a curve. So 0.2, 0.2, okay, so actually we can do this easily. Yeah. So first of all, let's draw a single helix, okay, single helix. First of all, you need to know the parametric equation for the helix, which is parametric equation for helix. Okay, that's a space curve. That's a space curve. Do we have do I have the formula for parametric equation of no, I don't think so, but actually we can write it, we don't need, we can write it, so because it's simple, okay. So let's see. Emirati, what does that mean? Oh, Emiratis are the native population and citizens of the United Arab Emirates. Their largest concentration is in the UAE, where there are about 1 million. Okay. Oh, okay. So interesting. Okay, so let's write the function. Let's find the parametric equation for. Let's write it. Okay. Let's derive the parametric equation formula for helix. Okay. If you search Wikipedia, it'll tell you right away. But basically, you have x, y, and z. Okay. So basically, the formula is x equals to, a circle is cosine t sine t. Okay, that's a circle. Now, so essentially, yeah. So this, So basically, so this is what you want. Cosine t, sine t, and t will just be linear, okay. Z will just be t, okay. So that is the formula. Now we need this formula to be in kind of Wolfram language notation, okay. So this is how you do. So you represent the parametric formula by that. So we can plot it. Parametric plot 3D. Okay. Now what is the hey bot. Okay. Okay, so parametric plot. Let's paste our, then t from 0 to 10. Okay, let's say 9. Let's see. Oh, there we have it. Fantastic. Now let's say, okay, yeah, that's perfect for our example. So now we got a bunch of, so So let's go back to the tube. So tube takes a bunch of points exactly. So now we have what we want. So we can what we can do is that okay. So these are points we want. We want to generate a list of points. Okay, so the easiest way is just to use table, but I don't like to use table, so I want to use so let me show you something fancier. Okay, so I'm going to create a lambda, which is a pure function. So in Wolfram language, this is a pure function. Okay. Which can also be written as which can also be written as like that. Okay, so then we want to map this function. Okay, let me just code it instead of talking. Okay, then we want to map this function to a list of values. So range is just like Python's range from 0 to 9, okay, in steps of 0.5, okay. Okay, so well, so that is harder to read, this one. So let's write it this way so it's more intuitive. Okay, so evaluate, so you got the bunch of 3D points. So you want to put this inside the tube argument. Okay, so let's do that. Delete those, we don't need. So basically that, copy, put it here. Then the tube thickness will be 0.2. Let's try it. Fantastic, my friends. Fantastic. After 20 years from this lousy image and much ado coding it, now we have just this single line of code. And rendered, this got thousands, 10,000, polygons. Now this is, this you can rotate, you can, it's using your graphics card to do it as well. When you, I wish I can regenerate this one, but it'll take me some, 20 minutes to actually recode this, so we can compare two different versions. So anyway, once we have one of them, we can create more of them. So just like the one on the right side. So let's do it. Okay, so tube this is one of them. Okay, copy. Actually, I type fast much better in emacs. Okay, so basically we want let me show you. Okay, so this is what we got. This one, we want to turn that into actually let's stop this idiocy. Let's use the the advanced way. I'm just going to show you the power, the advanced Wolfram language syntax instead of the easier to understand but more cumbersome notation of the function. So this is the lambda, where the pound sign, the number sign stands for arguments. So pound sign means the first argument, equivalent to pound sign 1. So if you have pound sign 2, that's the second argument. That represents the second argument. Then this ampersand symbol is a syntax shortcut to represent the function. So I explained this many times. Okay, so actually let me do it again. Let me explain one more time. Okay, so this I'll show you several equivalent syntax for these. Okay, so that's also equivalent to that, and that is also equivalent to that. Okay, so all these three are equivalent. Okay, and then this is also equivalent to that. Okay, so you see all these four are equivalent, syntactically equivalent. I did a video about 3 or 4 months ago, just search on YouTube, that I explained this meta syntax in detail. So now anyway, so we have this one. So let's go back to here. So so that works. You can see it does work, but we need 3 of them. Each one will be rotated a little bit. So let's see the beginning point, x, y. Okay, so basically you just want to add cosine and sine. Okay, so it's cosine and sine. You want to start at a different point. We want to rotate the helix basically. So cosine and sine, you want to plus t. Okay, plus how much? How many degrees? 120 degrees. So a full circle is pi, is 2 pi. Okay, so a full circle is 2 pi radian. Then 1/3 of it is 2 pi over 3. Okay, so you basically want that. Okay, plus that. Okay, so you can see, so that. Okay, so for example, we can plot our tube. Yeah, okay, you can, if I rotate it, you cannot see it, but anyway, so let's okay, let's do this. Okay, then where's the tube function? Copy copy back to Emacs. So wait, yeah, so this is what we want. Okay, let's try. I'm pretty sure it'll work. Do it. Fantastic. Now we just need one more. Fantastic, man. Okay, copy that. Let's just one more. What? Yeah, I need to write a Wolfram Language mod in Emacs Lisp so that I can type in Emacs. So divided by 3. So 1/3, 2/3 times 2/3 times, where is my key? Okay, this is kind of stupid, but this is actually the intuitive way to write this. So okay, so anyway, let's not talk too much. Let's just do that. Copy it. Do it. Fantastic. Okay. Yeah, so that's what we want. A twisty pipe. Okay, I think maybe that's it for today. I got lots of things to do. I need to update all these transform 2D plot, plain tiling. I really need to work on this. It's been delayed for plain tiling we talked about yesterday. I need to update this package. But it's been an hour, so I talked, I'm gonna work on them offline, I guess. That's it. Thank you guys for watching. If you like my stuff, buy it. Okay, donate, Patreon me, PayPal. You can see all the links on my website. Or you can buy my Emacs tutorial or JavaScript in-depth tutorial. And one more thing I want to say, so if you are interested in Wolfram Language, it's free. You can you can download it. You go to my website, just search for XahTV Wolfram Language free, then you'll see this page. You'll get it free if you buy a Raspberry Pi, if you are into kind of do-it-yourself stuff. Or you can download Wolfram Engine, it's free, or download Wolfram Script if you are kind of the Unix, you are into Bash or PowerShell kind of, you need to, if you want the most efficient, using Wolfram, if you want to use Wolfram language to do sysadmin, okay, if you want a replacement for Bash, for Z shell, for TC shell, for PowerShell, a magnitude more powerful, not more expressive language for doing those things, you download Wolfram script, which is free. Okay, so it allows you to use the Wolfram language, just like what you've seen, the same syntax, everything, to write a Bash script. So that's a Wolfram script. Okay. But then if you want graphics, you can download, Wolfram Engine. But actually, if you don't, it's free, but you don't get graphics. If you want graphics, you need to go to, the Python Jupyter project, which they have a package that integrates Wolfram Engine. Then, so you have to download Wolfram Engine and also the Jupyter. Just search for Jupyter Python Wolfram Engine. Then you'll be able to do basically what I do today. Or just buy it. I would recommend it. Bye, guys. Go here and go to, where's my Google? Go here. Yes, Wolfram script. Well, Wolfram Engine works with Jupyter. Wolfram Engine and Wolfram script, they are essentially the same thing. They are just the Wolfram language. But however, Wolfram script is designed for you just run shell scripts. No graphics, no sound, no just a script. So if you are using Jupyter, which is the primary, purpose of Jupyter is for you to have a graphical notebook. Therefore, it doesn't make sense to use it with Wolfram script. I think it does. I think you can. I'm not exactly sure because I haven't installed them. I'm using the Wolfram Inc. They gave me the Mathematica I'm using. Okay, bye. Okay, actually, I need to, have this on my screen for a while so that Google, YouTube will take this as the main screenshot for my YouTube. Actually, there's more improvement. You see these kinks? You see this kink? I can remove, why don't we try it? I don't want these kinks. I want it to be smooth. So how do you remove the kinks? Well, you look at the documentation for tube. Okay, so there is an option, I believe. The radius of the tube can be specified if no explicit okay, so you can use also Bezier curve. Oh, okay, so that's probably what I should use. Yeah, but Bezier curve, right now I'm using line segments to generate the cube. But if I use Bezier curve, it's more complex. You see, Bezier curve is control points P1. I'm not sure that will work, but let's try. Okay, let's actually just try it, because you know, this is the interesting part. Okay, so actually let's copy that. You know, let me show you the, you know, the power of Wolfram language. So actually, so you know, I really need a Wolfram language mod so I can prettify the code in Emacs. So instead of tube, yeah, so instead of that, so I say here Bezier curve. Okay, now I hope you don't need extra control point. Okay, so Bezier curve, that's right. Okay, actually, let's just try that. So okay, so let's get this clean. Okay, so you can see what is going on. No, I don't think it works, because you know, actually we need Bezier curve 3D. Now, do they make it? It also works in 3D. Okay, but it might be, you know, because when you have a Bezier curve, you have control points. But I don't have any control points, so I don't think it'll work. Let's just try it. Yeah, it's missing. You see, it's missing the one we changed. But can we fix it quickly? So let me try to do it. Okay. Bezier curve. So Bezier curve takes a bunch of points. Okay, so actually, I think maybe this. Okay. Do it. Nah. Okay, anyway, that's it.